Today we are going to go through, no, not that one, not that one, that's the one, page 37, no, sorry, 38, page 38. So this is what you did over the weekend, in theory. I don't know how many of you watched the videos. I mean, it's up to you whether you do these things or not. If you had done it, then this will be a review, which will mean that you'll be improving your memory curve, right? You'll be doing this. You'll be like, oh, and I'm going to get my stronger memory here. Whoa. And so you'll be like this. If you're doing it for the first time, by the time your quiz happens on Thursday, you're going to be here, right? So, but if you did it twice, then you'll be here. And if you have no idea what I'm talking about, that's okay. Order of operations. Everyone knows BEDMAS? Yes? Follow the order of operations. You must, when combining, adding or subtracting with multiplying or dividing, you have to write out each step. You can choose not to, okay? But I'll let you know that I have to write out each step to get the answer correct. And I have been doing this since 1987. Okay? So I don't know how many 30 some odd years that is, 34, 36, I have no idea. 30 something years, more than 30 years that I've been doing this. I have to write out each step so that I don't get the wrong answer. Okay, so if I have to do it, chances are you will also have to do it. I know there's always going to be one person who's like, no, I can just do it in my head. And then I'm like, well, no, maybe you can't, but all right, you know. Then there was, what was his name? Oh, not Jeremy Tam. What was his name? Todd Huang, who went to, where did he go? One of those big universities where big brain people go. And he was like in grade 9 when he took chemistry 11, like enriched. And then he took like AP Chem in grade 10. And then he was taking courses up at the university. He could do this in his head, but I can't. So, all right. So follow the rules, write out each step separately and round at the very end only. You also have to remember your addition and subtraction rule. Tell your partner without looking at it, what is the addition and subtraction rule? Then tell them what the multiplication and division rule is. Okay, addition and subtraction, round to the first uncertain digit. Multiplication and division, round to the least number of sig figs. And in most of these questions that are the tricky ones, you will be doing both these rules in the same question, one after another. So you have to remember the rule and then switch gears and remember the second rule. All right, so here are the most easy of all of the questions if we are only multiplying and dividing. This one, you just go, oh, I just round to the least number of sig figs. All right, so I take these numbers here and I say, plug these into your calculator, make sure that you are getting one of these two numbers. See if you are getting either 28.5609 or 41,241. If I don't see you pushing buttons on your calculator, then you are not working correctly.
Yes.
If you've plugged it in and you get 28.5609, you are using your calculator correctly. If you get 41,241, call me over so I can help you use your calculator correctly. Yes?
You're gonna need some help. How's that? How are you Okay, so what you're gonna do is you're going to go 4.7, and then times 3.2. Now, 4 doesn't matter. 0.873. Now we're gonna divide by 0.014. Yes. Now we're going to divide by. Yes. Okay. What else do you have? Yes. Okay. So is we are going to multiply by now we want to divide by 0.0. And now we want to divide by so there is no, we cannot times it because that would because you're being multiplied but in the denominator. So your calculator needs to know that it's in the denominator. Okay. Anyone else calculator difficulties? No? Okay. Regardless, we are rounding to our least sig figs. We have 3 sig figs, 3 sig figs, 3 sig figs, and 2 sig figs. So we should take our 1, 2 sig figs here. We look to the number to the right. That is a 5. So we round up and it becomes 29. Okay? All right. Example 2. Let's keep going. La, 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 la. La, 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 la. All right. Try this next one. 8.79 times 14035. See what you get. This is on your next page, page 39. Page 39. Fastest way to type this in. Fastest way to type this in, 8.79 times 14035 divided by 3.8 divided by 200 divided by 87. If you're just multiplying and dividing everything in the denominator, you can just divide by, divide by, divide by. Yes? That makes it a little faster. You can still use brackets on the bottom if you want to, but this is a quick way of doing it. You should get 1.8658. Yes? What is our correct answer there?
1.9.
How many sig figs here?
1.
How many sig figs here?
5.
5. How many here?
2.
2. How many here? Oh, and you know where I hid it?
Oh.
I hid it on the bottom in the middle. Do you know where I'm going to hide it on a quiz and a test?
Let me guess.
Probably on the bottom in the middle, somewhere I'm going to hide it. It's not going to be like the first number you see, because that's too easy,
That's actually supposed to be 2.
right? So it's going to be 1 sig fig. So this is going to then round to 2. Okay? All right. Now we get into the tricky part where you're going to have to do both least sig figs and you're going to have to do the first uncertain digit. Now, in this case, because we have brackets around the 6.8 plus 9.2, we are going to do that first. 6.8 plus 9.2. Which rule are we using? Least sig figs or first uncertain digit? First uncertain digit. So we're going to say, here is my uncertain digit, the 8 and the 2. I add those two and I get 16. If this was my final answer, if that was all I was doing, if I was not dividing by 3.65, would this be a correct answer? Is this the correct answer to 6.8 plus 9.2? No, because I need to go to my first uncertain digit, which is in the 0.1 place. So it's going to be 16.0.
Wait, do we put that for the answer now?
Now, so this was step 1. That's why you have to write it down, because if you just say, oh, I got a 16 on my calculator, and you keep going and you're like, I got 2 sig figs, you're going to be out of luck when it comes to your final answer. Because how many sig figs do we have here?
Are we including the 0 or no?
Are you including the 0 or no? How many sig figs in 16.0 where the 0 is uncertain? 3 sig figs. So now you have a 3 sig fig number. This here, this bit, actually has 3 sig figs. It looks like it's got 2 sig figs and 2 sig figs, but when you add them together, you get 3 sig figs. So we're going to have 16.0, which is 3 sig figs, divided by 3.65, which is also 3 sig figs. So we have 16 divided by 3.65 is 4.3836. And we say I've got 1, 2, 3, 1, 2, 3. That means we need to have 1, 2, 3. We look to the right. That is smaller than 5, so that then becomes 4.38. Is good? Oh, and we're going to scribble out these diamonds. I think I had them here from when it was like COVID time, because like we couldn't finish anything during COVID time. But we're going to learn it this year because, like, back before COVID, we always did it. Always, always. And we're bringing it back. We're bringing it back. Because we now no longer have to, like, be hybrid in... Did you guys ever have to do hybrid? Where you were, like, partly in school and partly out of school? Probably not. You were probably still in elementary school during COVID? Yeah? Okay. Anywho, regardless... Regardless, we are now on example 4, which is not enriched, it's just regular, okay? Now we have, and actually I'm going to grab this so I can bring it over here and we can do it over here. There we go. Which operation will we do first here? We're going to do multiplication. So this is going to be step 1. This will also be part of step 1. It doesn't matter which one of these you do, but this is going to be what you do. So we have 50.35 times 0.106 is 5.3371. Which rule am I following at this point? First uncertain digit or least sig figs? Least sig figs. And my least sig figs, I have 4 sig figs and I have 3 sig figs. So that's going to be 1, 2, 3. Yes? Should I round it off now?
Yeah.
No, do not round.
What?
Do not round. You'll see why in a minute, okay? Do not round. Do not round. Let's do the other half. 24.37. Oh, we're gonna do this. We're doing this bit here, okay? The yellow bit, because we have to do the other multiplication before we can do the subtraction. Multiplication before subtraction. So 24.37 times 0.181 is 4.41097. Which rule are we following for this? Least sig figs. So 4 sig figs, 3 sig figs. So we're going to say we got 1, 2, 3 sig figs. And now we're going to subtract. When we subtract, well, let's just throw all these numbers in there. Let's get our answer. 5.3371 minus 4.41097 equals 0.92613. What rule should we be following here? We just did a subtraction. The uncertain digit. Okay, so we need to go to the uncertain digit. Who is the uncertain digit in 5.3371? Remember, these are my sig figs because this had 3 sig figs. Who is the uncertain digit in 5.3371? The 3. That's our uncertain digit. In our other one, we also had 3 sig figs. Who is the uncertain digit in 4.41097? The 1. And both of those are in the 0.01 place. Yes? So that means our uncertain digit is that 2 there. Yes? You look puzzled.
Yeah.
Okay, so this is the 0.01 place, yes?
Oh.
And this one is the 0.01 place. And so this is our 0.01 place. That is our uncertain digit. Okay? And now what we're going to do is we're going to round there. And so we look to the right and we say that's a 6. So this becomes 0.93. And doesn't matter that our initial digits, we had a 4 sig fig, a 3 sig fig, a 4 sig fig, a 3 sig fig. Our final answer has only 2 sig figs. But remember, the adding and subtracting can totally muck you up, right? It doesn't have to follow that pattern. I believe that if I was really clever over here, let's see what happens with various degrees of rounding. So this first one, we have no rounding. Okay, so we've got those first two numbers, and we have not rounded them. That's like what we just did. Okay, no rounding. Our uncertain digit is in the hundredths. Our uncertain digit is in the thousandths. Oh, how did I? Oh, I've got a different number here. I need to fix this. Fix. That's okay. Doesn't matter. Either way, it's all good. Either way, we'll end up with our hundredths position. Yes? Now, our second one, if we keep one digit after the uncertain digit. Now, you have to be careful with this because you can't just say, oh, here's my 3, so I'm going to keep the 7. You actually have to look beside the 7 and say, that's a 1, so that's going to stay as a 7. But I still keep in mind that my uncertain digit is there. Okay? Here, my uncertain digit is the 3. So I'm going to be looking at the 6. I look to the right of the 6. That's a 5, so that's going to round up to 7. Yes? Not 6. I don't just cut it off and say, oh, that's a 6. I don't just keep the 6. I have to say, what does it actually round to? So if I keep one digit after the uncertain, I still get 9.3333. So that's 0.93. So that's okay. Is good? Same rounding, same number, 0.93. But what if I had rounded all the way? What if I had said, okay, I've got 3 sig figs here, so let's round that to 5.34. And I've got 4 sig figs here, so then let's round that to 4.404. And now I do my subtraction, and the number I get is 0.936. When I round it, now I get 0.94, and that is incorrect. Because it's not 0.94, it's 0.93. So this is what we call a rounding error. My favorite way to do these questions is to keep the entire number in my calculator. Do you all know how to use your memory button in your calculator? No? Okay. If you don't, call me over sometime during the work time and I can show you. Okay? So, yeah. If not, and if you have to write down all the numbers, you can write down all the numbers. But if you don't want to write down all of the numbers, you can write down all the numbers to the uncertain digit and one more. Does that make sense? And that one more digit should keep you from having a rounding error. Okay? So you can keep all the digits. You can keep one digit past the uncertain digit. But if you round it off all the way, you risk getting the wrong final answer. You won't always get the wrong final answer, but sometimes you will. Okay? And in fact, in grade 12, I know for a fact there's one question in grade 12 where if you don't keep 2 digits past the uncertain digit, you actually get the question wrong. So if you want to keep 2 digits past the uncertain digit in hopes of not getting that one question in grade 12 wrong, if you have me as a teacher next year and remembering that, then you can do that. Ha! Okay, we're not going to do example 5 yet because this is stuff for later, okay? Right now, what I would like you to do is these questions. Now, we're going to get rid of all of these diamonds. Okay, and this is page 41. And you're going to do numbers 1 through 16. Okay? And you should be able to, I would recommend, and in fact, I've written it down to complete on your own sheet of paper. And the reason I recommend that is that for most of these, especially when you get to question 6 and beyond, it becomes hard to write down everything. But if you want to cram it in, whatever. Okay? And remember, if you're just multiplying and dividing, you can just do it all in one step. You don't have to write things down and get your numerator, get your denominator, just do it all at once. Okay? But the moment you put in adding and subtracting with multiplying and dividing, that's when you want to write everything down.
Oh my God.
35. Okay, your attention please in 5, 4, 3, 2, 1. That means we're stopping talking when I get to 1. We don't talk anymore. Oh, that's people outside my classroom. Gustavo, could you close the door for us, please? Okay. So hopefully you can't stay here if you're talking. Got it? So we have 4x plus 2x equals 6x. Hopefully from math, you're familiar that we can factor out the x. Yes? So we could have, instead, we could have 4 plus 2 times x is equal to 6x. We're familiar with that from math class? Okay. What we are going to be factoring out here is the times 10 to the x. All right? And we're going to first start with adding two numbers where the power of 10 is the same. So we have times 10 to the 3 and times 10 to the 3. So we have 4 plus 2. 4 plus 2. We've factored out the times 10 to the 3. So that gives us 6 times 10 to the 3. So far, so good? Okay. Let's do it with sig figs now. This time we have times 10 to the 4. So we're going to factor out the times 10 to the 4. And what we're left with then is our mantissas, or our coefficients, 4.5 plus 1.75. 4.5 plus 1.75 is equal to 6.25. And we still have the times 10 to the 4. Now, this was an addition. So are we going to least sig figs or the uncertain digit? Everyone should be able to tell me at this point. Least sig figs or uncertain digit? Uncertain digit. Those of you who don't know are going to be crying on Thursday. If you're having trouble, be sure to come in during Flex over the next couple days. All right, because we have our quiz on all of Sig Fig Math on Thursday. All right. Okay, so here's our plus. So we're going to the first uncertain digit. Our uncertain digit is in the 0.1 position here. It is in the 0.01 position here. That is our uncertain digit and our uncertain digit. That means that these two digits are both uncertain. How many uncertain digits are we allowed to have? Only one. Whoops. So we have to cut off there and we're going to round. So we look to the digit to the right and that is a 5. So that then becomes 6.3 times 10 to the 4. Is good? So factor out the power of 10. Add the coefficients or subtract the coefficients and then round them to the correct sig figs. If your number is not in scientific notation, you will need to change it into scientific notation. Now this is beautiful if your powers of 10 are the same, but what if they are different? Yes? Well, remember that powers of 10, what they're doing is they're moving the decimal place around. Yes, if I've got 10 to the 3, then the decimal place is in a different place than if I have 10 to the 2 or 10 to the 1. So I need, in order for my decimal places to all be in the same place, I need my powers of 10 to be the same. So here we have an example where we have 10 to the 3 and we have 10 to the 5. We need those powers of 10 to be the same in order to be able to factor them out. I can't factor out a 10 to the 3 and a 10 to the 5 because they're different. So you can change either one. You can change them both to 10 to the 3 or both to 10 to the 5. We'll start by going to the higher power, the 10 to the 5. So I'm going to take this 10 to the 3 and change it into 10 to the 5. Did I increase or decrease that number? I increased. I increased by 10 to the how much? 10 to the 2. That means this first part of the number has to decrease by how much? 10 to the 2. That means I need to move my decimal how many places? 2 places. And I need to move it to the left. So that's going to become 0.075 times 10 to the 5. And now we have a common factor that we can factor out. We can factor out the 10 to the 5. All right. I'm just going to bop down here because I've done it down here. So we have our common factor, 10 to the 5, 10 to the 5. And now we have 0.075 plus 5.25. Those numbers you add on your calculator. Do not, when you're adding and subtracting in scientific notation, do not type the power of 10 into your calculator. Leave it alone. Only this on the calculator. Not the power of 10. Okay, so we add those two up and we get 5.325 times 10 to the 5. And then we have to say how many sig figs. What did we do? Did we add and subtract or did we multiply and divide? We added, so we're going to go to sig figs or uncertain digit. Uncertain digit. We've got that in the thousandths and we have it in the hundredths. So we're going to round to our first uncertain digit, which is that 2. We look to the right and that becomes 5.33 times 10 to the 5. Is good? Okay. Now remember I said this, in this case, we went to the 10 to the 5. We're going to watch what happens had we chosen to make the other one times 10 to the 3. So we're going to do it the other way. Okay? Same question. It's just this time, instead of changing to the power of 10 to the 5, we're going to change our 10 to the 5 into 10 to the 3. Okay, so this time we're changing this whole number here. So in this case, this got lower by 10 to the 2. That means our 5.25 has to go up by 10 to the 2, which means we end up with 525 times 10 to the 3. Yes? So now our powers of 10 are 10 to the 3, and our coefficients are 525 and 7.5. Yes.
So, is it wrong if I put 525 points, like this, after the 525?
It's weird. It's weird to do that.
Is it wrong?
It's okay as long as it's not your final answer.
Okay.
If it makes you happy to do it in the short term, yes, that's okay.
Okay.
Okay? Now, we've got our uncertain digit is the 5. Our uncertain digit is the 5. This is the 0.1 position. This is the ones position. So our first uncertain digit here, when we add these two, remember you do this on the calculator, just this part, not the power of 10, just that part. 532.5, we have to go to the ones position. So that then becomes 533 times 10 to the 3. Yes? And now, this is unfortunate because are we in scientific notation? No, we're not. So we need to convert it into scientific notation. In order to get this thing, this has to get smaller by 10 to the 2. That means this has to get larger by 10 to the 2. And our final answer is 5.33 times 10 to the 5. Okay. Is this kind of ugly? Yes. Yes, it is. Is there going to be one question with this on your test? Yes. Yes, there is. Are there going to be 7 questions? No. No, there's not. So if you decide at some point you're like, this adding and subtracting in scientific notation is more than I want to do with my brain, you will not be like throwing out the whole test. Do you know what I mean? Like you'll be limiting yourself to 98% maximum rather than 100% maximum. But in the grand scheme of things, how often will you be doing this? Not very often. Okay, it's not like a skill you will need all through grade 11. So if you've never learned this skill, you'll lose a mark on this test. If that's important to you, then learn how to do this. If it's not important to you, then you can go, this is a skill where I'm just gonna not worry about it too much. These are the sorts of things you need to think about as you get into higher level courses. And especially when you go to university, sometimes you just have to be like, I'm just gonna learn these things and I'm gonna learn them well. And then I'm gonna not worry about that as much. I never learned how to do that until I was in like 3rd or 4th year. So I spent a lot of time in 1st year trying to understand everything. And some things my brain was not yet ready for. And so I wasted a lot of time doing that. And I could have gotten more marks just focusing on the stuff I knew how to do. Anyway, just a little efficiency life lesson there. You cannot just add or subtract numbers with a different power of 10 and hope that you get the correct sig figs. Do not ever plug it into your calculator and be like, bam, I got it, it's 3. No. You must convert to the same power of 10. You must add and subtract the coefficients only, then round to the correct sig figs. And then once you've got it with your power of 10, you'll write it in correct scientific notation. Now, we have another example here, but we're going to skip it for now. We'll come back to it in just a moment because I wanted to show you the alternate method. Alternate method, which is going to work unless you have really big powers of 10. Okay? But here I have a 3 and a 5. Those are okay. Yeah? I can actually, instead of putting them both in the same power of 10, I can expand them into standard notation. Yeah? 7.5 times 10 to the 3 becomes 7,500. 5.25 times 10 to the 5 becomes 525,000. My uncertain digit is in the hundreds position, and my uncertain digit is in the thousands position. When I add them up, I have uncertainty in the hundreds and the thousands. My first uncertain digit is right there. So I'm now going to round. I look to the right and I get 533. Here's where people will often make a mistake. They'll just be like, 533, 3 sig figs, I am done. What's wrong with that answer? I have 533,000, yes? Have to make sure you've still got the right number of zeros at the end. Okay. Would you like to go through one more example? Yes? Okay. So here we have, let me grab this. You can choose to convert to the higher power of 10. You can choose to convert to the lower power of 10. I usually convert to the higher power of 10. I feel like more often it leaves me with my answer in correct scientific notation more often. But regardless of which method you use, sometimes your answer will not be in scientific notation. So you pick. Here, who is the higher power of 10? 10 to the negative 5 or 10 to the negative 6? Negative 5. Excellent. Okay, so I'm going to leave this one alone. This is just going to be 1.4 times 10 to the negative 5. That's going to stay as is. This other one, though, I'm going to take this and make it 10 to the negative 5. This half of the number went up by 10 to the 1. That means this half has to go down by 10 to the 1. So that's going to be, then I'll move my decimal place one place to the left, 0.567. Stupid pen. Okay, again, we're going to factor out our 10 to the 5. Okay, and now we have 1.4 minus 0.567. We're doing a subtraction, so we care about our uncertain digit. All right, 1.4 minus 0.567 is 0.833 times 10 to the 5. Negative 5. Oh my gosh, I dropped my negative sign. Whoopsie. Okay. Now, our uncertain digit is in the 0.1. Our uncertain digit is in the point thousands. So we need to round to our first uncertain digit, which is here. We look to the right, that's less than 5, so that becomes 0.8 times 10 to the negative 5. At this point, you recognize, uh-oh, I am not in scientific notation. So this is going to become then 8 times 10 to the negative 6. 1 sig fig in the answer. Okay? So your homework is to finish numbers 1 through 16 on that other page and to do numbers 1 through 6 on page 37. Page 37, numbers 1 through 6, and page, I think it's 41. Is it?
Yeah.
Yeah, page 41, number 1 to 16.